say this. I forgot to say that we record these so we can play it back
Okay.
for other people later. So,
Okay.
hey, welcome to the Shop Class Podcast. We started the recording late, but everybody's here. And we have Erika Alvarez from NASA, and she is she was a student at my school, but not my student. She graduated before me. Please take it away. Sorry about that.
Yeah, that's okay. So I'm really happy to be here. First and foremost, I want to say that, to me, hands-on work and doing things where you can actually make something is probably one of the most important and empowering things that anybody can do. And so, what I wanted to talk a little bit about today, before we did the recording, I was mentioning that originally I'm from West New York, New Jersey. So my hometown is the actual town where your host, is a teacher at that high school. But I also went to school in Pennsylvania. I went to Penn State University and I studied aerospace engineering. So I'm going to talk a little bit about what I do today, and then I have a few questions that I think were sent to me in advance, or we can do some Q&A after we talk a little. So I'm going to pull up.
Do you know how to? You can present. You just click present on the right, and then you could share your whole screen. Or if you need to send something to me, then I could present it. Whatever's easy.
I will. Let's see if I can share this right here.
Also, I want to say hi to Francis. Francis, what's up? Francis is super cool. She's building an electric car with her dad, and it's called Tinker Engineering. We could put the link in there later for you. She's got like a whole YouTube channel and everything.
Well,
oh yeah,
thank you.
Cool. Look at this! Wow.
So can you all see this presentation?
I can. Yeah.
Okay. So one of the things that I wanted to talk to you all about today, even though I'm in Huntsville, Alabama, actually one of the cool things about the pandemic is not just that we can do things like this and we can all meet from different parts of the country, but I'm actually right now working at NASA headquarters, which is in Washington, D.C., but obviously I'm working from home. One of the major things that I'm doing right now is I am the what we call systems engineering and integration, which is really a field in and of itself, for the Artemis missions. So right now, I don't know how many of you have heard of Apollo. Maybe many of you have seen Apollo 13, have heard of Apollo 11. And all our missions, in which we did the first lunar landing in 1969. What we're doing with Artemis is we're trying to return to the moon. And so what I wanted to show you all is a little bit about kind of the nuts and bolts. I kind of crafted this for this group to talk a little bit of the nuts and bolts of how we do the design work. And then I'm going to talk to you a little bit about the mission.
That's so cool. Thank you for doing that.
And one of the first things, when we talk about going back to the moon, it's definitely a large architecture of spacecraft and designs and components that help us get there. For several years, here in the top left, I worked on the Space Launch System, which is actually the rocket itself that's going to carry the astronauts. Here on the bottom left, you can see the Orion Spacecraft. The Orion Spacecraft is actually the capsule where the crew sits in, and they sit on top of the rocket, and it has its own solar arrays.
Can you click on the one you're trying to show? Right now, we just see the slide, the original slide, the first slide.
Let's see. I didn't move.
So click on the second slide, and we'll see what you're or present. If you click presenting, then you'll be able to. You might be on a laptop, or then you're limited on space.
Let's see. Let me move this around a little bit.
If you send me that, I'll be able to.
Are you on the? Are you seeing the title slide?
Just the first one, yeah.
Oh, that's weird. Let me try to unshare and then start sharing again.
Okay. There you go. Cool.
Let's see. What if I share my entire screen?
Oh,
Let's see
that's
what.
a lot better. I know what you're talking about. Yeah, if you only show one tab, and when you float between tabs, then it kind of like it's stuck on the tab that you were. There we go. That's
Okay,
it.
that's better. Because I
Nice.
have multiple monitors, so as long as I'm
Okay.
sharing the right thing.
All right. We're cooking with gas. Here we go.
So can you see on the top left, we have the Space Launch System, which is the rocket.
Yeah, is that Orion?
The bottom left is the Orion capsule, which is
Okay.
actually where the crew sits on. And the rocket, really all it's doing is pushing as fast as it can and taking the capsule, all the way into lunar orbit.
Is
It
that
has its own.
considered like stage one?
Yeah, stage one is the first stage is the solid rocket boosters that push you, and it really does all the power to take you out of Earth's gravity. And we have 4 engines at the bottom of the rocket. That is the first stage. When the boosters fall off, those liquid engines keep pushing. And once the tanks are empty, it separates, and we have an upper stage that pushes us again with another engine. And then that capsule stays all on its own, and it has its own small engine that continues to push the astronauts. So it's multiple stages, and we do that because we don't want to carry. We call it parasitic mass or like extra mass. If you have an engine that's pushing, there's no need for the engine to have to push and cause the force to push that much if the tanks are empty and you're not using it anymore.
Cool.
The other big thing we're working on right now is in the top center. It's called the Lunar Gateway. And the Lunar Gateway, think of it as like the International Space Station that we have now orbiting around the Earth, but that gateway orbits around the moon. And it'll be a permanent station.
We were
Um,
looking at a video before you came in as a pregame, and
mhm.
and it was so awesome to learn that it's amazing that you're actually going to put a space station, but not just around Earth, it's around the moon. So we're going to have like a
Yeah.
moon for the moon in a way.
Yes, and that space station is going to be. It's going to have experiments. It's going to have a robotic arm. It's going to have habitat for the crew. It actually is the beginning of eventually, if we wanted to have a transport to go to Mars, it's basically showing us like how that station works over time, so that if you put a propulsion system on it, one day you would be able to build a transport for Mars. So we're kind of learning around the moon, because for us to go to the moon, it's really 3-4 days, and then you can return. So it's a week-long trip. But to go to Mars, it's like 6 months or longer. So we want to kind of test things out at the moon first before we start getting ready for Mars. The other big system we're working on is the suits. And I'm going to talk a little bit more later about like all the key technologies, like how we're trying to build suits that are outfitted, for our astronauts to do a lunar walk. We have lots of little rovers and science experiments and payloads that we're dropping on the lunar surface ahead of time. And we're also working on the right, you can kind of see part of a human landing system or a lander. And I'll talk a little bit more about that, because you need something to take the crew actually down onto the lunar surface.
I would say that is this right? That I would say if you've seen Apollo 13, the movie, just as an overview,
Yes.
the idea is that, you're going out there and then you have to park in an orbit and then you bring stuff down to the moon.
Yep.
But instead of just a single mission, you're talking about setting up a whole system where it's recurring and you have a station out there.
That's right. And the whole goal of what we're trying to do is making this sustainable, so that it's not just a one-time go, and then maybe return, but it's trying to create a long presence when not just the station, but eventually our lunar base camp.
Nice.
So we'll talk a little bit about the base camp too.
Yeah. So it's like going on a long trip, but instead of just going for a weekend, you're like moving houses.
Yeah.
You're setting up a vacation home so other people can go visit too.
Yeah, and the rocket itself, I know somebody asked the question about, the rocket, but I worked on that for several years, and not just the engines on the bottom of it, but also this is actually taller than the Saturn V. If you look at the Saturn V from Apollo 11, this is taller. And so it's not only just the world's largest rocket, but it's also a major manufacturing, construction, lots of drawings, everything that it takes to just stack and put all this together to make sure it's assembled correctly, and lots of different designs that we came up with until we selected this one.
Wow, that's cool. I stood next to the Saturn V at Cape Canaveral, and if anybody's ever done that, it's a lot bigger than you realize. It's
Oh,
like,
it's huge.
yeah, that's amazing.
So how do we start things? One of the ways that we do, just like you would do anything at home, is we come up with lots of different ideas, even of like what the shape of the rocket should be. And we have major wind tunnels at NASA. One of them is in Virginia at Langley. And we put the rocket in the wind tunnel. We kind of change the angle, or what we call the angle of attack, that we put it in, and we put it through a lot of stresses in terms of aero, so we can see how that's going to put load on the vehicle and how the shocks are going to form, because you're going supersonic speeds, right, velocities. And so you're looking at all those different angles across the rocket. Where will the shocks be, and how will that affect the loads on the structure itself? And we use a lot of that data to build models, so that we can apply that to a structural model and show whether or not our materials will be able to, survive beyond the environment.
That's cool. I want this guy's glasses. This guy looks cool.
So lots of testing, and then lots of manufacturing. As I mentioned, the rocket itself has 4 engines at the bottom they basically, just suck in liquid propellant, liquid oxygen, liquid hydrogen. If you're familiar with the space shuttle, we had 3 of those engines on the space shuttle orbiter. On this rocket, we have 4 of those liquid rocket engines. So combined, those 4 give you over 2 million pounds of thrust, in addition to the thrust from the solid rocket motors. So to build the tanks, the tanks are massive because they just hold this cold fluid.
So you have 6 engines running at the same time, right?
Basically 2 solids and 4 liquids. And when you look at the tanks themselves, we machine a lot of those barrels, but then we have to join and weld the different barrel panels together, and then weld in the domes and put the caps on them in order to create the whole thing.
I think you got some shop teacher ears perking up. Machining, welding.
Machining, welding, and also, like, if you just see the cranes up at the top in the yellow, which are massive, we had to have a lot of people that are familiar with construction design, and being able to design the size of the cranes, everything that we call the ground support equipment, to be able to move everything around, because it's such a big investment and it takes so long to make these that you don't want to drop them inadvertently, right? So it's a big operation.
Materials handling, yeah. Yeah, we got a crane over there at Memorial. No, there's no crane.
And then
we have an overhead crane for pulling out engines. We have a cherry picker.
And some of the cranes that we use at NASA are custom, because people don't usually have to use cranes this large or in this application. So lots of times, we're like a custom job.
Francis, did you ever use an engine hoist to pull out the engine of your car?
No, we used a piece of wood in our hands.
All right, well, it's a Volkswagen, so you could just muscle it out. All right, so yeah, at NASA, they're not going to do that, so all right.
And in this image, we do lots of different types of welding. The welding that you saw on those tanks is actually something called friction stir welding, which is where the 2 materials, they come together and they actually spin at a rate in which the friction itself causes them to form and bond together. The good thing about that type of weld is it's not a traditional like torch or electron beam or something with heat where you have a heat affected zone that degrades the material. The friction stir welding actually makes a very, very strong bond. But we do have weld specialists. A lot of them come from, for some reason, Ohio State. We hire a lot of Ohio State grads in welding. But all the folks that are experts in this, they come in and they work on what we call the weld schedule. What is the spin rate? What are the materials? How do you go and do the process? And you have to show that it's repeatable so that every time we can understand how strong the bond is going to be.
That's cool. You can get more specific with this question later, but I saw pictures of stir welding and I never understood, do they shield it from oxygen while that's stir welding, or does it not need that? But we can get into that later.
Yeah, we can get into that. When you think about traditional forms of welding where you're actually melting, right? And then it's joining and going together, you definitely want to keep the oxygen, away from the crystal so they don't go in and like damage the metal, right? And later you end up getting oxidized layers and things like that. The friction stir, I think, and this is something, again, we'd have to call our metallurgist folks. It's not as sensitive really to that as the heat, the traditional heating type of welding. But we do watch out for contaminants. All those things are critical, making sure that we don't get bad material properties because we had something, being exposed to the metal during the weld.
Cool.
The other thing, again, this is what this person is showing here. He's a technician, and he's showing you kind of this ball-like structure that's called a pogo accumulator that's on a liquid rocket engine. And what that thing is, it's filled with a gas. And so if for whatever reason the vehicle ever starts seeing this kind of vertical up and down motion, that gas volume in there will kind of help dampen things out. So it's really like a big damper. But the unique shape of it actually makes it very difficult to make. So one of the things we've done to make things a little bit cheaper is that's made through additive manufacturing, where you can actually take powder, you can put it on a bed and then you apply heat in layers and then it actually builds up and creates the part. And what's cool about additive manufacturing,
nice.
It's almost like rapid prototyping, if you think of it that way, but with metal. And it's good because it reduces the number of welds, so your material is strong, you don't have a lot of defects. And with this manufacturing technique, you can make any shape you can think of, dream of. The biggest thing is just going in later and doing a polish and getting it, nice the way you want it. But it's very repeatable as well. So if you have a drawing, we have a lot of people that put the software into the machine and they work and make the part, and then they just kind of crank them out.
That's amazing. So you got 3D printed parts on a spaceship going to the moon.
The other thing we have, and I know this isn't part of this presentation, but like on the International Space Station, we have an additive manufacturing machine there that if we sent the software for a tool, they can make it in space. And it's better that way than trying to anticipate ahead of time, let me carry all these things. You can carry the equipment, carry what's needed. And then later, if you find out you need something for a repair, you can send up the code, the programming, and then make it while you're up there. Nothing this big. It's usually smaller parts.
Cool.
The other really big thing, I noticed you maybe had a double E here in the crowd that you mentioned, Ron. So I kind of wanted to.
I don't think he's here tonight, but there's Actually, yeah, no, there. I think Yas at Evo's here. He works at he does power. Yeah, he does power. Good.
So one of the big things, it's not just mechanical, but it's also what we call software, avionics, power systems, all those electrical engineering type jobs. And we have a huge facility where all the brains of the rocket, full scale, are put in together with all the harnesses, all the wiring, and we send software to it. And the boxes think that they think they're flying, and you can see how they respond to one another, how they react, how they send commands to one another. And we use all this testing to make sure that the brains of the rocket are working.
Wow, this is amazing.
You kind of have to be a little bit OCD for this job because, very neat how they're wiring the cables and putting in all the bundles and getting everything together. But then the cool part is once the facility is up and running, you can bring in other boxes from other parts of the system and test them all together in a lab, and then look at the data right after.
Just curious, like what's the highest voltage you're dealing with? Is it mostly like in the hundreds, or is it up higher for something different? Oh, I just guess it depends. It depends.
It really depends. I would say, we have everything from, lithium ion batteries, to, again, some of our spacecraft have our solar arrays. So we've got a wide variety of power uses across the system.
Sure, yeah.
And the other thing, I wanted to talk a little bit about here was testing. You could see that red crane. I think that's a custom crane that we ended up getting. But this is a huge building that we built just to be able to take the tanks and like push them and pull them and twist them and try to just show, like, in real time, did we build it how we expected it to? And then, of course, because we're engineers, we're like, let's just break it and see where the limit is.
That's the best. That's awesome.
So our test engineers had a lot
look
of
at that.
fun. They had a lot of fun with this test because one of the things that we did was we said, okay, we're going to basically fill it, pressurize it. We even put in all the foam, everything that was needed for the insulation. So it's just like a flight tank would be. And then we tested it. And, once we did that test, we basically were able to see that it basically went well beyond, what we had designed the tank to do. The tank itself, just like any engineer you meet, is going to probably over design it. And so we wanted to say, okay,
Whoa.
did it break? And then when it broke, is that exactly how we predicted it would break? And so inside, you can kind of see the ISO grid of the machining of those panels, those aluminum panels, but you could see that it kind of unzipped where a weld line was, where all these barrels came in and joined at a weld, which is usually your weakest point, right? So we thought it was great data, well worth the test, because then we could go back and compare it to our models, and just kind of say, yeah, this is what we predicted.
Wow, that is so cool.
The other part of testing is at the end of the day, those tanks are going to be filled with liquid hydrogen, liquid oxygen. You could see the 4 engines there on the bottom. A test stand in Mississippi, and we put the whole stage, we call it a stage with the 4 engines on the test stand. Of course, lots of people to move this. It gets moved by barge, actually. And once we put it on there, we call it a green run test because it's really like a checkout before launch to make sure it's going to work well. And the green run test itself, it runs probably about 500 100 seconds or so. But it's, like I said, it's 2 million pounds of food used to work down there. And I mean, it's just like hearing sea coming out as steam because it's
Erica,
liquid hydrogen, liquid oxygen. And
you're getting lagged when it's playing the video. So maybe you could hit pause and then explain it only in between, because for some reason that's what happens. I don't know.
yeah, and the thing is, you know, when it fires, it actually makes steam because it's liquid oxygen, liquid hydrogen, so it almost like rains on you, but it's super loud.
Wow.
So I'm gonna try to play it.
Okay, yeah. Okay.
So yeah, you can kind of see lots of facility work, lots
I
of
see.
test engineers,
You're on a barge when you test it. Is that right?
lots of basic.
I think the
It's
video.
on a test stand.
Oh,
Like we
test
move
stand.
it on a barge and then we put it on the test stand.
Oh, I see. Okay.
And then once everything's ready to go, you know, we send it to Kennedy Space Center, which is, most people are familiar with where our launches happen. And that's where we, you know, start to bring the crew in, and the crew starts to get ready, you know, to go on board the vehicle.
Yeah, like most people
The
go
big
to
part of the
Disneyland,
working
but
with the,
yeah. Oh, most people go to Disneyland, but if you just go an hour from Disneyland, you could go see a rocket launch. It's better than Disneyland. You know.
at one time I went with a friend of mine, and I worked on it. We redesigned the part that was on the space shuttle. And when the launch was over, we were so happy. We just went to Disney after. So that's a kind of a bonus of, you know, going to Florida, get to see a launch, and then, yeah, we're going to Disney. Um, and and the cool thing, you know, about working with the astronauts is just, they're people just like us. They're humans just like us. They learn through repetitive motion, learning how to do the same thing over and over, going through procedures. And so we build the capsule in mind for something that they can operate. Um, you know, Artemis is called Artemis because that's actually the twin sister of Apollo. And we thought it was a good name from our mission because, as you all may know, during Apollo, we had several astronauts that stepped foot on the moon, but Artemis will be the first female astronaut that steps on the moon. And then the next man that goes with her. So that's why we wanted to give it that name, because we felt it was appropriate, you know, for what we were trying to accomplish.
Maybe it'll be
Also,
Astronaut Abby.
I
She's
know.
I saw her on a presentation recently. She's like this super popular astronaut that's doing social media now. I saw her with
And
Colin Furs on the encouraging the Shell Eco Marathon participants.
And the big thing about being an astronaut is, you know, lots of times the first time you apply, you don't get in. But I know lots of astronauts that applied 3, 4 times and then they got selected. And once you're an astronaut, that's it. You go into the astronaut class, you get trained, and then you get assigned a mission. And at that point, your career starts. You know, so you could come in as an engineer, you can come in as a doctor, come in as a payload specialist, a scientist, and then just apply. You know, just keep applying. And our goal, as you mentioned in the beginning of this, was to stay. And in addition to that, we're going to the South Pole because in Apollo, we always went to the equator. And there's special science that we want to do in the South Pole because there's areas that we call permanently shadowed regions that have never seen light before. And we don't know if there might be ice or there might be something there that, you know, we want to be able to explore and do experiments on and see and collect samples.
That's where the aliens are.
Well, so and the cool thing is, you know, if there is water, we want to be able to know how to convert that to oxygen, how to convert that to things that humans can use, so that we can prepare for Mars, you know, doing the same type of work. But again, I think someone asked a question about radiation. Yes, there is some radiation exposure, but the crew has, you know, special shielding as well as some of the equipment. A lot of the electronics have to be shielded against radiation. And if there is going to be a radiation event, we can detect that and go ahead and let the crew know to kind of get in a safe space within the capsule.
Oh, wow. Okay.
Lots of little robotics, so it's not just big things, but lots of robots and experiments that we're sending down. Someone asked ahead of time about collecting samples. We have some sample return missions, things like that. Lots of technology projects built on research, as well as some of them are universities help us with these small companies. Lots of big startups where people are trying to send scouts, and also our industry partners helping us build satellites or other things to help us with communications and solve lots of issues around the moon. The big thing now is the lander. We're actually competing. We have 3 companies that are competing right now to build the first lander. Some of you may have heard of these. One is Blue Origin has a national consortium of companies that are working with them, as well as a company named Dynetics and another company named SpaceX. And the 3 right now are competing as to be our commercial partners to bring the first crew back to the lunar surface. So that's a kind of a fun.
So exciting. I'm a big Elon Musk fan. However, Blue Origin is Jeff Bezos, and he just recently stepped down as CEO, and a lot of people speculated, hey, he's going to focus on Blue Origin.
Yeah, and the cool thing here, is that lots of both here where I live and all different states, Florida, Texas, California, you can find all these companies. They have a big national team that's working really across the country to bring all this together. Same thing for the Space Launch System, same thing for all these major systems. You have people all across the country building this. And so pretty soon, I think within about a month or 2, we'll find out who was selected as part of this competition.
Oh, wow, no kidding. Very cool.
The spacesuits, we could have a whole session just on spacesuits, but all I'll say about the spacesuits is that we're trying to make them light, flexible. We also have to adapt them for different sizes of crew members. And then, of course, they have to be able to carry the oxygen, make sure they can take out the CO2. They have power, they have some lighting. And we do a lot of the training in Houston at the Johnson Space Center on training the astronauts with the suits. We even have a micro buoyancy or a big pool that we, I don't know if you've ever seen the Bruce Willis movie, Armageddon, where they're kind of in there in the water in the pool training. We do a lot of that in Houston.
So cool.
The Gateway is the space station for the moon. That's a whole, it's not just the US, but lots of international partners that are bringing different parts of the Gateway. We just signed an agreement with the European Space Agency as well as Canada, and working one with the Japanese to bring different modules and different parts to this station.
We were watching the video before, and we see it's like modular, so people can make a vehicle, and as long as they got like a Lego piece that connects on, the Lego connection is standard.
Yeah, the docking mechanism is standard. It's actually an international standard, and we provide the drawings and we provide all the information, and then they know how to build something that mates to it. Or in some cases, if someone needs help, NASA can help provide the mating mechanism so that it's guaranteed to fit. And we do lots of testing, ahead of time to show how the 2 systems will dock.
Oh, and just as a side note, they're probably going to do a lot of spacewalking out there on that. I'm guessing, because I know they do a lot of spacewalk maintenance on the International Space Station, which is so cool. You can watch that happen. I guess they'll be doing the same when they're building out or repairing this one as well. For the moon.
Yeah, eventually they're going to add an airlock. And once they put the airlock in, that's like the little compartment they get in where they can close the door. They have the suits on, and then they go out. And then when they come in, they're able to get it pressurized again. They can take the suits off, and then
it's like when I walk in my house, there's like a little vestibule.
Yes.
I take
Yes.
off my snowboard boots and I don't track mud
Yes.
into the house. This is
Yes. It's an
maybe a
airlock.
little bit different. It's a little bit different, I guess.
So that's big for us. Once we get the airlock, we can do those, we call them extravehicular activities, or those astronaut walks outside. And then the rover is a big part of what we're doing right now, because the crew can only walk so far away from the lander. But the cool thing about the rover is we're going to send the rover down first, let it do remote operations, let it do science, let it go do traversing, let it do things kind of like the Perseverance now on Mars, right? And then it'll mate up with where the crew lands, and now it acts as a mobile vehicle, so we can go further with the astronauts.
So I'm guessing that's an electric vehicle running electric motors, got batteries, right?
It's got power systems. It's also got to be able to survive, because in the South Pole, there's periods of darkness. So it's got to be able to survive a good bit of time in the dark. So that's one of the big requirements.
Because Francis is putting an electric motor in an old Porsche, Porsche 914, and also Eric is working on an electric vehicle. And so basically, it's the same thing out there. The only difference is that pack, if it gets too cold, probably you lose a little bit of power. So you got to have some sort of pack management system, I'm guessing.
Well, we have thermal experts also, that are working on how hot and how cold, your whole system will get, to make sure that it can withstand what we're calling the lunar night, right? Those extreme cold temperatures, which your power systems will have to kind of stay in a hunker down mode, and then be able to start up operations again after.
Cool.
And then the base camp, I talked a little bit about that, but the base camp is, the lander will be there. We'll have a foundational hab on the lunar surface. We're also working on a rover that you can see kind of in the middle, that's pressurized, so you don't have to have a spacesuit when you're in it, and you can kind of live within it also, but it can go around and do stuff. And that we're building, working on those rovers out of the Johnson Space Center in Houston. So that's kind of a big, what's coming next, as we put more things on the surface.
Nice. And then the first traffic light will be up there soon.
And then all the controllers from the ground here, the control center in Houston, will be watching, making sure everything's working, talking to the astronauts, making sure everything's safe. If you've ever seen Apollo 11, that's like the Gene Kranz, or the guy that wore the white vest, and he was kind of running everything and making all the decisions, when things were going wrong. That's another critical function that we have, that we hire folks that can do that. They know the whole mission, they know everything, and they know what calls to make. And then at the end of the day, just to kind of start wrapping up here, all kinds of things like samples, learning about lunar dust, how that impacts all our systems. Even it gets in things like seals and clothes. And of course, if you bring that back into the lander, it can dirty the air. And now you got to have filters. And, there's just all kinds of little things and little details and engineering solutions we're trying to come up for all these different challenges, that we have out there.
Wow.
And then, just to kind of say, I think there's a lot of different things that are part of the Artemis mission, everything from hands-on work to manufacturing to engineering design to testing. I mean, I think I've shown you a little bit of everything: operations, working with the crew. But what I wanted to say is, I know someone asked this, but for me, I think having teachers that, as you learn how to do small things with your hands, whether it's, soldering a part together, or, learning how to use a CAD design, or learning how to, read a drawing, the more little things that you learn, you kind of say, oh, well, I could do this, or, oh, this seems very reasonable, or this was easy to learn. And you kind of pick it up little by little. So that at the end of the day, if you're in a clean room and you're building engine hardware, or you're out there testing, you feel comfortable because you've had all those little building blocks and all those people that have helped you like build confidence along the way. And I don't think we can ever do that without teachers. I mean, that's my personal opinion. I think that's how you get there. And
I paid her to say that, so you know.
Well, because I think that a lot of it is confidence building, and all of us have like a little thing inside that tells us, gives us doubt or says maybe we can't do something. But sometimes you need like that outside, especially as a student, someone to like believe in you, and then you kind of, start to realize that you can do it, right? And somebody's got to give you a chance, right? Somebody's got to like teach you how to use a lathe or teach you how to use a piece of CAD software or teach you how to read a drawing, and you kind of learn along the way. And those are important skills. Because now I buy all the machining stuff at home. I buy our saw, our table saw. I buy everything in the house.
That's awesome. That's awesome. This
So
is great.
Hi, you guys hear me?
Yeah, Evo.
Yeah.
Hey, what's up?
Hey.
Well, hi, Erica. It's a pleasure, I guess, to talk to you. It's nice to have you. It's funny, but I'm pretty sure that you were the person. I remember I was in class. I was a senior, and then you came to say hello to everybody in the class because we were taking physics. And I remember somebody asked you what is how does a jet engine work? And you you went on and how to explaining it. So that was great. Anyways, I just wanted to agree with what you said about like the inspiration and like teachers, because I think I told this to Ron, but I feel that way, right? Like when I was in school, I wasn't the most confident person in the world, but then Ron kind of created circumstances for like making me making a robot, or me trying like SolidWorks, or me going to like this auto shows or whatever. And that created that creativity to become like an engineer. So I do agree teachers are like in the front end of like our society or whatever.
Yeah, and the other thing I'll say is, as a kid, I do remember, math and science or something that I was always interested in. I always wanted to learn more. I would learn a little something, and then I want to learn the next thing, and then I'm curious about that, and I want to learn the next thing. That is the one cool thing about this job. You're always kind of learning lots of little things, and you're around people that are the same way, and they're all curious. All the people I work with, one day my garage door opener broke, and my friend Jim is like, "Oh, I bet it's a circuit board. Let me come over. I'm going to pull it out. I can resolder and get a new resistor." And so you're working around people that in their home life, but also at work, are all about like tinkering and solving little problems and doing things. And that's really the fun part of being in a group of people that are all this like that,
That's awesome. And what a cool connection like that we had Evo, who actually went to the same school, and you came and visited the class, and now you're on this thing. This is just such a cool thing.
That is crazy, because I remember going many years ago to a physics class and a science class at Memorial, because my sisters were working there. And I was home for a holiday, and I said, "Oh, I'll come by if they buy me like Sal's Pizza or something, I'll come." So it's just it's like come full circle.
That was awesome.
Yeah, definitely cool. I do have one thing to say and one question to ask. I think I like a NASA. So I'm studying data science, getting my master's in data science, and I was always curious about I guess like doing failure analysis. So I know NASA does have a failure analysis data set, which I tried to read, and I was like, no idea what I'm reading, because there's a lot of components and variables. I'm like, what is this? But I look forward to one day, I guess, understanding it. And second thing, I am curious to know, I guess, how realistic is like some movies, like where there's like like something terrible is happening in the station, and then they don't know what is, because there's only like a few people in the station. They don't know what's going on, so they have to contact NASA and then there's like a bunch of engineers and NASA like getting together, like 10 or 20, to try to figure out the solution. I always wonder, is that just real, or is it just like a movie thing?
No, that is real. So the people down in mission control have the drawings, they have the layout, they know how everything was designed, and they're the specialists in that equipment. So when things do go wrong, that's why they want to be able to communicate with mission control so that the engineers come up with a solution, and then we send a procedure up. So that is very common.
So I also have a question. So you mentioned like tinkering, and I'm in 7th grade and I'm 12, and I run a YouTube channel called Tinker Engineering, and I want to inspire other kids to do their own thing. And so I'm converting like a Porsche 914 to EV, and I really love to make things. So here's my question to you. Did you like to make things when you were younger? And what's the coolest project you made growing up? And is that the project that got you into engineering?
Okay, so first I'll say from like kindergarten when I was little, I mean, I tended to gravitate towards Legos, making all kinds of things, just creatively, just having a mixture of Legos, not like today where they give you like the perfect kit. No, it was just like, here's a whole bunch of crazy Legos and putting things together. And I would say that later on, when I was kind of close to your age, I would build, like if you go to the hobby shop and they have like the balsa wood planes that you can put together with just glue and wood, and some of them have rubber bands, and you can put those together and they can kind of spin around. Those were kind of some of the best things that I liked getting for Christmas, and like microscopes and little science kits and things like that. Later, I would say when I was in high school, at Memorial, for some reason, they had an aerospace class, and we were all able to build.
Doug Nerlich
had the best class ever, and we were able to build little model rockets. And you can go to the park, and it has a little motor on it, and you light it, and it just kind of goes. I think for me, that was when I decided, this is what I'm going to do. We did a lot of other things in that class with aircraft. And again, I could have worked on aircraft. I also liked Formula One. That was another thing that I feel like I could have really gotten into. Anything that went fast, like that was my thing. So the louder, the faster, the better. But I think probably, just building small rocket motors. And then in college, we went and built a big one and launched it. And I built a couple of small sats that you can see in some of these pictures. One was handheld that went up with a weather balloon, and I built it out in Colorado. So again, once you start doing like all these little things, the big rockets and the big satellites is just a bigger version of that small thing. And once you see it that way, it's like, okay, I could do it,
That's awesome. Everybody should give Frances a follow. I put the Instagram in there. It's the journey of how she's converting this car to electric, and she interviews people, and it's crazy. She goes to the junkyard and gets parts for the car. She goes to EV West to get advice on batteries. It's amazing. It's really amazing. Yeah, that's cool. Good.
Yeah, I just did.
Go ahead, Tim. You got questions?
Yeah, I just followed her, so
Oh,
I'm
nice.
excited to see what happens. And
Thank you.
you're welcome. Follow back.
Yeah. Tim's got the wood turning. He's an incredible wood shop teacher.
So I just want to second what you said about starting small and then, going and just kind of evaluating. And I was having this conversation with the kids in my civil engineering class today because it's a semester course. And, when you're doing a multi-view drawing, especially like orthographic or isometric drawings, and I'm trying to tell the kids, like, a multi-view drawing of a battery or anything really is a multi-view drawing. It doesn't matter whether you're drawing a battery, a bracket, a part, a building, rocket ship. It doesn't matter. A multi-view is a multi-view. And it's nice that, you kind of reaffirm that, starting small is still good because the terms, the concepts, the technology, the machinery, the things like that, a lot of it is just the same. And then eventually what ends up happening is, you want to do bigger, better, you got to get bigger, better machines. So, I mean, I just really enjoyed what you said about that.
Cool.
I also think that it's kind of like you accumulate information over time. I mean, it's just like anything in life. That's the one thing that I found that, I would learn how to do one thing, and then I'm very much, and it's just my personality type is like, okay, I checked that box. Like, what's next now? And then, okay, I checked that one. Okay, now what am I going to do next? And I have other people that are in cahoots with me too, that are all kind of doing the same thing, But even speaking of civil engineering, I went one summer to a university, you just reminded me, and we were all told to build a bridge project, first out of wood, and then out of, like, they give us these plastic materials. And I think a lot of people went through the wood part, and then when we got to the plastic and we had to do all the soldering, like, a lot of people gave up because, like, it would fall apart and it would warp, and it was just a huge pain. But then if you stick with it and you actually have it work, and it's like, wow, you were able to do it, a lot of it is just not quitting and not giving up. Because, I mean, I had great grades in high school, and then when I went to college, like, I was just average, and that was a bummer. But I realized, like, if you just work really hard and you have grit, and maybe you're not the smartest, but you have a lot of grit, then you're going to be better than those people that are like, you know what, this soldering, I can't get through this, I'm giving up, I'm going out instead. That's kind of what makes to me, that's what, whether you make it or not, is just giving that extra time because you're passionate about it and you're like, okay, I'm not going to give up,
Nice.
Yeah, and I see that in the woodworking realm. Like, the kids, and I'm sure a lot of the other guys that are here, and gang that's here can attest to it, is the kids will run across a project or a problem that they're I guess that they found, and then they're like, well, I don't know what to do. I cut a piece too small, or I made the dado too big, or just XYZ, insert problem there. And I tell them, I said, it's a craftsman can hide their mistakes, and it's not giving up. And 95% of the people that are going to look at this thing that you made aren't going to realize that you made X problem, or there was X problem. And it's just one of those little details that like I had a young lady, and she was building a pine bench, and there was problem after problem. Things didn't glue right, and things didn't fasten the right way, and things would warp and shift and things like that. And it was just like, all right, how are we going to solve the problem? And the problem was, make this a little bit better, or add this extra support piece and things like that. And she was tickled pink when she walked out of the room, because she has this project and she has it for the rest of her life. So it's one of those things where it's just, you gotta go. And, anybody can take two pieces and put them together, but it's figuring out, the problems that occur is where you're really starting to learn.
Nice.
And we have a saying in the industry that, the first unit you're still learning, because it's that first time that you're making it and you're building and you're putting it together. I'm sure, the rocket, as we build it, we have little errors where maybe someone misread a drawing wrong, or they machined something in the wrong place, or they put the drill hole in the wrong place. But you know what? You fix it, you patch it up, you repair it, you move on, you accept it, because nothing's going to be perfect. And at the end of the day, when the rocket flies, like, I mean, we'll know the little defects that were in it, right? Because we signed off on all of it. But to the outside people, it's working, it's functional, it's doing what it's meant to do. I think when you make it, you're more critical of it, as opposed to other people that are like, wow, that's a nice bench, And then you take those lessons learned and you roll it into the next one and the next one, or maybe you make the design a little bit better so it's not so prone to flaws. That's normal.
So I said to a kid the other day in class, and I only see the student once a week for an hour because of the whole COVID and the hybrid and remote instruction. So anyway, student says to me they want to make a bowl. They wanted to make a bowl for their mom for Christmas, and this was before we went out on quarantine in December. So we finally got back into the school, and I said to the kid, "Do you still want to make this bowl for your mom?" And he goes, "Yeah, I want to make it." So we selected a couple pieces of wood, and next thing you know, he says, "Well, what do we do now?" And I'm like, "I don't know." He goes, "Well, what do you mean you don't know?" I'm like, "I don't know. I never did this before." And he's like, "Really?" I says, "Yeah." I said, "Believe it or not, I'm learning through you, because that's what this process is about. You know, I'm learning how to do something that you wanted to do. And you know what? I can make it, we can figure this out together, so that next time I do it with another student, I have the answers." And it's like the student teaching the teacher, and it's doing problem solving together. So we left class on yesterday. I think it was yesterday. We left class, and he goes, "What are we gonna do next?" I'm like, "I don't know. I really don't know." So
It's cool. You got a community.
yeah, it's a one-to-one thing, and you can really only pull that off with a handful of kids, though. Like, not every kid will accept that, and certain kids will realize what you're going through with them and appreciate it.
Yeah. But speaking of groups and whatnot, and like working with people, we had a question come in from Qasim, who graduated from Memorial, and he's now doing he's studying aerospace, but he's working on an electric vehicle company in Silicon Valley. But he wanted to know like how much time do you spend doing research versus prototyping? I guess that would be depending on what team you're on. I'm not sure. That's a good question.
So we have a couple of NASA centers that their primary job is just research. They're research scientists. We call them technologists, and they're there working in laboratories, building all kinds of new technologies. Like in Ohio, we have the Glenn Research Center, and a lot of their focus and their work is research. And so if that's what you like to do, to just go out and find ways to solve problems that haven't been solved before, there's a whole community of folks that do that at NASA. Now, when that gets ready to become a design and to make something, one of the key things that I found that ironically I was good at was being able to get researchers to talk to the engineers that are now going to design it and build it, and have those two come together to do something. Because sometimes the researchers keep on researching, and I want to learn more. I want to make it better. And so we have a saying that, best is the enemy of better, because at some point it's got to be good enough. And you're like, look, we got to get these drawings out. We got to get this to the machining shop. We got to get these parts made. We got to order material. Like, we got to stay on a schedule. And then the folks that are doing research are like, yeah, but I could do this and I can make it better that way. And I could. So the key is, if you have people that could bring those two cultures together, that's a job in and of itself.
Oh, I see. Managing the teams, right?
Yes.
Interesting.
So I think I have a similar quote for something you were saying about perfection, which is I think perfection is the enemy of execution. I think it goes. And what I do agree, even on my job, so I work for Con Edison, so we do have some of those issues where engineers and the people who work at the field, sometimes they're having trouble communicating, because the engineers are great at designing and prototyping, but then they forget that this is going for somebody who's working with their hands on, and they might see this design and be like, this is never going to work, because maybe the shape or maybe the tool that you're giving me is not the right tool. So I think it's interesting that similar issues in a different industry.
So I'm a little unique, because when I started at NASA, I started in a hardware design group, and we had to learn, and you guys may know this term, but it's design for manufacturing and assembly, which is basically a CAD will let you put anything on a drawing. I mean, whatever you want. But you got to be able to sit with the machinist and even the person that's going to assemble it all to say, is this going to work? Because you can come up and dream up with this crazy thing on the computer or on a hand drawing, and then you take it to the machinist and they're like, I can't make this, or I'm going to try to make it and I'm never going to be able to meet the tolerances, and I'm going to keep scrapping it and scrapping it, scrapping it, and it's going to keep getting thrown away every time and we'll never finish it. Or you'll make it and it can't assemble with the rest of it. So sometimes you have to be able to sit with even the technicians, and when they tell you, hey, but have you thought about doing it this way? They're more hands-on, they're abstract, they are really good at being able to see things in multiple dimensions. And you kind of have to listen to that, because there's been times I've been in a clean room and I'm not a technician, but they're like, hey, can you turn this wrench because your fingers are really small and you can get in there, and the technicians can't get their thumbs in, their hands in there. And I'm like, okay, I'm the engineer, I'm not really supposed to do this, but I'm the only one that has the small fingers. So tell me how much you want me to torque this, and I'll like do it as you tell me, and try not to strip the bolt, you know.
Wow, that's a cool story.
But it's like, who designed this thing that only somebody with these little fingers could get in here? That's messed up, you know.
Yeah.
And then I'll go back and complain and go, hey, and then you got a manager like, why is this taking so long? Because we couldn't freaking get in. We couldn't get in there, you know. So that's a flawed design.
Mm-hmm. It's funny because now, okay, so Frances is working on cars. I'm sure she's come across stuff where you look at the car and it's, let's say it's an old Porsche, and you're like, why did they make it like that? I can't get my wrench in there. Well, because they're designing it for assembly on the manufacturing line. They don't care what happens to the car afterwards. You know, so you find this a lot in product design. I wanted to ask, okay, we have another question, and this is like shifting gears a little bit. How much payload can that SLS take?
So, you know, payload is anything, you know, for those of you that may not know, it's anything that it can basically carry as cargo. You know, it could be like one of those modules for the gateway. It could be a lander. It could be the capsule. The Space Launch System, you know, if you were going to the moon, it can carry over 40 metric tons, because the capsule itself is like 26. And then the bigger version of that vehicle will be able to carry another 10 metric ton, like piece of the gateway or a module, or a big component. But that's going to the moon. If we were actually taking something to low Earth orbit, it can carry over 100 metric tons, because that's not that far. But our rocket is really made to carry big payloads to the moon. But if we wanted to point it towards a planet, you know, we can point it towards a planet too, and it'll carry something a lot smaller because it's further. So the rocket's capable of, you know, wherever you want to point it, we can then calculate and tell you, okay, so here's how much we can carry, you know.
That's cool. I have another one. This was, I thought, a clever question. Can you tell us a story about Artemis that we're not going to hear on TV? Maybe like a fun story that's probably the news won't care about, but like, I don't know, something cool, like what happened? I don't know, something like that we can relate to. I don't know.
I mean, I think the cool thing about Artemis, you know, a lot of people think, well, it's like Apollo, we've been to the moon, so it's going to be the same. When we came up with Artemis, you know, one of the things we wanted to do was to be able to say, we want to go to a part of the moon we've never been to. We want to do science that we haven't done. And the other thing that kind of blew my mind until I started working with people is that depending on when you launch and how you line everything up will depend on the exact landing location and the exact landing site. And so we keep our options open on, hey, maybe we want to land by this crater or we want to land over here. And depending on the season of when we launch, then we say, okay, that's the best time to go to this location over there. And we kind of like to keep our options open. But once we build the base camp, we're committed, you know. So there's a whole group of people that are, and they all work for me, and they're fantastic. They're brilliant. And they're all like, well, if you want to launch over to that landing site, you can only go, these 2 or 3 months out of the year. But if you want to go to that other one over there, that one's going to be a little bit easier, but in the winter. And so people think, well, it's easy, just go to the moon, point and shoot and land. But there's so much geometry that comes into it, that even up to, as it gets closer and closer to launch, that's when we'll really know where we're going to land.
That's wow. That is awesome.
Yeah, I actually read a similar story with, I'm not sure who was that landed in Mars, but whatever landed in Mars, they were saying, because Mars is actually 1 hour day. The day is like 25 hours. So at some point, you're working, but you have to adjust your time to Mars. So you might be going, you might be working night shift because, it's just the way that I guess the time is not in Mars. And I forgot who the story was from, but it was really interesting because that's things that you might not consider. And then, from a non-astronaut perspective, or yeah.
Yeah, I will tell you, the people that work on like Mars Perseverance, that just landed on Mars, and the people that work on those rovers, they give a name to like their spacecraft. The spacecraft usually live for many years, so they have birthdays for the spacecraft. Like they celebrate it like it's a thing, like it's a person. And usually, if you're on a project like Perseverance, you worked all these years to the design and build up in the flight, but then you work many years after, like watching the science and celebrating it and getting the data. And it's multi-generational, because you may retire and then somebody that worked under you comes in and takes over, and it's like 24/7. So the scientists that work on those missions, I used to have all these like conferences with them, and they talk about how, like, when the spacecraft finally dies, it's like a human dying,
Wow. I think we got a question coming in from Eric, but he's going to ask it. Go ahead, Eric.
Yeah. So I actually have a bunch of questions, but I think the biggest one that I wanted to ask was when I watched the video on your plans and stuff like that, you were talking about mining the ice on the moon. And that got me thinking about, how is that going to affect the tides on Earth? How is it going to affect the moon's orbit? What's going to end up happening?
So, one of the things is when we take samples, we take like small little core samples, or we take, something on the surface. Like we're not planning on, like in Armageddon where they do a big drill and, they affect the whole shape of the moon. We're not, we're definitely not allowed to do that, because like you said, the gravity, that is from the moon is actually what controls our tides, here on Earth. We also have to be careful not to contaminate things. So we're very careful about, not creating a lot of contamination, trying to keep things as pristine as we can, for the science. But yeah, we don't plan on like, changing the gravitational effects of the moon, to affect things here on Earth, because that would be really dangerous.
Okay, so I guess to follow up, but because I remember in the video it said something about using the ice, the hydrogen for fuel and oxygen for the astronauts. So I guess that was confusing.
And I think it's to test the concept, because when we go to Mars, we want to know if we can actually do mining there, because otherwise you have to carry everything. But on the moon, we have plans to drop logistics and drop, food and, underwear and all that, medical equipment, that kind of stuff down.
Oh yeah, the video is great. It explains that they're going to use contractors to deliver stuff ahead of time. I got a follow-up question on the when it comes to the using contractors. I know SpaceX does reusable. Is the Orion first stage, is that going to be something that is reusable, or is that a one-time usage?
So the capsule itself is one time. And that's because when it comes back to Earth, it has a lot of heating. And so from the heating, it's not like reusable, and it actually splashes down in the water. And it has a heat shield and a parachute that slows it down.
Oh, yeah.
So we plan to make that over and over, because if you had to make it reusable, you'd have to make it a lot stronger and heavier. And then heavier is less optimized,
Oh,
and
yeah. Sure.
that's
Yeah.
mass you can use to take stuff to the surface, or water or oxygen.
Like you said, the parasitic, you're trying to get rid of everything you don't need.
Exactly.
What about the bottom part, the rocket part on the bottom? Is that going to be reusable?
Now, some of those came from shuttle, like some of the different rockets and the pieces we use on shuttle, and we are reusing those.
Oh, wow. Okay.
But then after like their first mission or so, like I don't know if we plan on reusing those or just putting new ones on.
Okay. Cool. Evo, you got a question?
Two questions. Well, one is kind of like a follow-up on this topic, and then I have a separate one. So I guess, I don't know, but I'm just curious, what is your personal opinion about, like, I guess, SpaceX reusing the rockets?
I think it's good. I think it's innovative. I think anything that's like, it's a big goal, and if they could accomplish it, and our commercial partners are showing us how to do it, I mean, I'm all for it, because, I think that one of the biggest things that we have to be able to do is to build a lot of hardware and build new things and test them and fly them to see how they work. And so if you could reuse to do that faster, I think that makes the design process and the improvements go faster if you can do it.
Evo, you got a follow-up?
Yes. So do you guys see, I guess, SpaceX as a competitor, or more like as a team? I mean, it's obviously two different companies, but like, do you guys, I guess,
It's a
ever collaborate
contractor,
together?
no? Aren't they like it's an asset?
Yeah, they're all commercial partners. All of the companies that we work with, like the Space Launch System has many companies that build that and come together. The lander, the different parts of the gateway station, to us, they're all commercial partners for us, right? So, we're able to, as NASA, give them different aspects of the mission to be a part of and to build. And we work hand on hand with them, to make them successful. So for us, it's not a competitive thing, because we're the government as NASA. We're here to facilitate, commercialization.
It's cool. Is there any question? I know that to be fair to Erika, she got up very early today to speak with do her job and speak with the European agencies and whatnot. So I want to be fair to her and give her, she doesn't have to stay all night. But is there any more questions from the shop teachers at all? This way we can get to that, and then Erika, you've done a lot of time already, so it's up to you how many more questions you want to take. Okay.
Yeah, if we have one or two more, but yeah, definitely, I'm getting a little sleepy because when we meet with the Europeans, it's early in the morning because they're on a different time zone.
Yeah. Okay, let's
I
see.
guess I had a question that kind of goes off of the fact that you're meeting with the Europeans here. Obviously, you're meeting with the Europeans, so you're working together. Are there any countries we're kind of racing against to try and do this and get to the moon? Or is like the moon a shared space that everyone's allowed to go and just hang out on?
Well,
So we have a lot of international partners that we're working with, to build international relations, to be a part of the Artemis mission. Every time we do that, we have a big announcement and we sign like an agreement of how we want to do things with them. So far, we've signed an agreement with the European Space Agency, which is it's like NASA, but it's a lot of European countries that come together for their space agency. We've signed agreements with JAXA, which is the Japanese space agency. The Canadians, because I think they're going to build us the arm, just like they have the arm on. It's like a robotic arm that was on station. They're going to build us one for Gateway. And then there was another country recently. oh man, I don't want to say the wrong one because I feel like it was Brazil, but I'm not sure. But anyway, little by little, it's a big part of our, domestic, as the US trying to build alliances and partnerships, with other countries. And so little by little, we've been signing on more to become a big part of this. Um, I would say for sure there are a lot of technologies that we work on that could be used and be militarized. So we do, it's up to NASA how they want to, build the partnerships, but we are a bit conscious and careful about that, to make sure that we're doing the right partnerships. Does that make sense, Eric?
It does.
Yeah.
Cool. Any other shop teacher questions? Let's see. I mean, these guys, the shop teachers in here, they're doing their thing, and this was a real treat. Erika coming in here. We had a lot of people come in. People were real excited. I mean, space is like so exciting, because you got a situation where it's the unknown, and also expansive. So it's very cool for you to come in, take the time to do this and whatnot. So I really appreciate it. And I
Yeah,
think
and Ron, I want to thank you because I've stayed in contact with you just because you've always been at Memorial trying to do good things with the kids there in New Jersey. So I stay in touch with Ron every once in a while to see how my hometown is doing. So when he brought up the chance to do this, I said, well, yeah, that sounds like fun. I haven't talked to a group of shop teachers before. And then you think back of every shop teacher you've had and you wonder, whatever happened to him? Or her. I did have one female in the mix. And so to me, it's important because you guys are kind of like the foundation for that next generation of people that, I mean, you'd be surprised what they're going to do, right? I don't know if all the shop teachers or science teachers that I had know where I am, but they were all part of it. So that's why I wanted to come here today.
What's cool is like all the stuff she's talking about now. Just imagine all the stuff she can't talk about. That we'll see in 10 years. So that's pretty cool. That's pretty cool too to know that that's occurring also at the same time.
Yeah. Lauren, you're gonna say something?
Yeah, I teach a freshman STEM class for like a STEM academy at our high school, and that's where I see the most girls in because it's this kind of rigorous application process, even though it's not for like necessarily the cream of the crop students. But today the girls were talking about like the idea of who's a perfectionist and not getting like that score on the test and just getting emotional about it. And I just really I think you have a good message about like accepting failure a little bit. Like you didn't have to have that perfect score in college and look where you are. And I have an identical twin sister who is a mechanical engineer at Sikorsky Helicopter. And she's always like, I can't present because it's like secret stuff and government work. And I look forward to sharing your ideas with her and hopefully making her more confident to share too. And I will definitely share with my students too. You're very inspirational and I love coming here and seeing some women with some voices, even though there's a lot of men in the audience, that we have a voice at the table. So thank you.
Hey, so lots of people always ask me, like I go every year to the Society of Women Engineers conference, and they ask me if I have a motto, and I tell them, in that movie Finding Nemo, where Dory's like, just keep swimming, that's kind of my motto because you just kind of keep going and plugging along, and you get there. But I will say that lots of times girls ask me, like, do you have to have a female mentor? Or because I happen to be Latino, they're like, do you have to have a Latino mentor? And I tell them, I'm like, I have had mentors that are men, female, like all different cultures, all different backgrounds. They come from, different parts of the world in the country. and like you can always find something in common with someone, really. And so that's a big part to me, is that no matter what, whether it's, you know, another female that maybe looks like me or not, I think the important part is just like being confident so you feel like you fit in. I remember when my boss said, "Hey, if you're going to go down to this plant at Pratt and Whitney, which they used to be part of Sikorsky at one point, he's like, you'll have to buy safety shoes." I'm like, "Okay, where do I get safety shoes?" And so he just sends me off to this, like, you know, machinist place over here that's got these nice steel toe shoes, you know. And, you know, I think I was the only one buying that size.
Yeah, there's barely any size for us, or there's
Right.
like using the DeWalt drills, the old style. Like my hand wasn't big enough to take the battery out. Like I couldn't. So
Yeah.
when I first started teaching like 15 years ago, I was selecting tools for like, if I can't use this tool, if it doesn't feel comfortable in my size hand, like it's not going to feel comfortable in a middle school hand.
And it was the same thing with like gloves, but eventually, you know, I'd have my own goggles or my own, you know, whether it was equipment or things to wear. And when I first started working the test stand, you know, I remember people were like, "Well, you know, it's just the only rule is don't wear a skirt and high heels." I'm like, "I've never worn a skirt and high heels. Like, really? I mean, I'm not that type of person, so it's not a problem." But then once you realize, like, hey, everybody's just out there doing the same thing, you become part of a group, and that's what's important, you know.
I just love how you were saying, like, I wanted to do like the projects that were like fast and powerful, and a lot of times, sometimes teachers will gear girls into projects that are a little bit more like aesthetic based, and not really showing like it's okay to like fast things, like it's okay to like the competition too, you know. So
yeah, I remember
and I think that's what Ron does, right? Cars are for girls too.
I think that I remember in CAD, you know, they were like, "Oh, you could do CAD, you know, for mechanical design, or like, why don't you do the architectural stuff and like put together a house?" And I'm like, I grew up in the city. I'm not interested in a house. Like, you know, so again, they try to, it's weird. It's unconscious, but they may be trying to like push you towards something. And then it's like, nah, I want to do this other thing over here, you know? And I think that's what's important, is to just listen to the students and kind of tell, and try to do it that way, you know?
You know, what's cool is that when I teach welding, obviously there's not that many girls that are, you know, have the instinct to come in and try and weld. So I have to recruit. But when I get them in there, what's funny is that I found welding gloves that fit women better. And it was designed by a female welder. And she has passed on, but her name was Jessie Combs. And she was the fastest, I think she still is, the fastest woman on 2 wheels or 3 wheels or whatever. She drove a jet car in the desert, broke records over 400 miles an hour. As she rolled and she got into an accident. She died on another record. She's trying to break her own record. But the gloves that she created and is endorsed by Lincoln Electric, I bought those for one of the girls in my class, and they fit way better, right?
Yeah.
Years later, 6 years later, this girl graduated. 6 years later, she went off and did some other career. She came back and she called me because I teach welding on the side now. And she said, "Hey, I want a refresher class. I still have those gloves, you know," and this and that. I was like, "Oh yeah, I bought you those gloves. It's crazy," you know? So, you know, even if the equipment doesn't fit you, you know, you can find a way. In this case, this inspired this girl because she made a connection, you know. But it's funny that, yeah, like, you know, as a shop teacher, you have to think like, okay, there's different size people, you know, and also people are coming from different walks of life, whatever. But you could always figure out a way to accommodate someone, you know, type of thing.
Yeah, and just being mindful of like accessibility, right? But you're just amazing.
So many people talk about inclusion, and that's what inclusion is. You know, inclusion, it's like this whole, like, yeah, you can sign up, take the class, but then do you feel like you're, like you're included, you're participating, you're working on a team and working with a group of people, and you're contributing. Everybody wants to feel like they contribute, it just makes you feel good. And so that's a big part of it. And like I said, I find I can be with a whole bunch of technicians and they'll be the first ones to notice. They're like, hey, that helmet doesn't fit you right. Here, take this one. And they're just that means that they're seeing you as part of the team, and that's a great feeling when you go home.
Yeah, that's cool. The funny thing is, for all the shop teachers out there, let me just show you real quick. This is not an endorsement. We don't get paid for this or anything, but here are the gloves, the Jessie Combs women's MIG welding gloves, and they fit perfectly. It's ironic. And this is Jessie Combs, and she is, I think she has the fastest land speed record out from Bonneville. I don't know, maybe 400 miles an hour. I have no idea. Anyway, just long story short, just thought I'd show you that. So it's totally doable to encourage the next generation from any situation, It's funny because just a little personal thing. So I did not have shop class growing up. And the ironic thing is, and I also did not like tight teachers growing up. The ironic thing is that I am a shop teacher and I'm a teacher. The way I learned automotive, the way I started was I would literally go to a junkyard in Hackensack and go draw pictures of the cars, because the guy he thought I was stealing stuff because I would go in there with a backpack and a pencil and a pad, So people are going to come from all over, but it's true. Sometimes you have a shop teacher that will just encourage you. And that's kind of what happened. Is I found some people that encouraged me to buy a car and work on it. That was a big step. That was like going to the moon for me,
See, and you can draw. I can't even draw. I'm in awe with people. I go into somewhere and I'm like, well, we need to do something like this. And they can just sketch it. And I'm like, I can't do that. I don't know how you do that.
I got you. It's simple. It's very simple. It's like building. It's like building. You lay it out first.
My hand just doesn't process and do what I need it to do on the piece of paper.
Teach me rocket science and I'll teach you drawing.
I think I got an F in art. It was the first F I ever got in 5th grade. I was so upset. The only F I ever got. I was so mad because I just kept erasing because it didn't look the way I thought it should look.
See, and now what I tell students about drawing is that drawings are not photographs. They're not supposed to look like photographs. They are detailed information about what you would like to convey. So that's why a drawing is actually better than a photograph, because a photograph is just a machine capturing light on a flat 2-dimensional plane. Whereas in a drawing,
at the end of 40 minutes, I've hand over this sheet that just has all these eraser markings on it, and I did a bunch of stuff, but it just didn't come out to what it was supposed to.
That's so funny. Well, I'm gonna stop the recording here, and let me just say, so I really appreciate you joining us. Is there any way to follow you, or is there do you do a social media thing? Okay, so
I'm not a big social media person. I know.
Okay.
Work gives me a hard time about it.
Okay, well, there is you're on LinkedIn, so if anybody wanted to connect with you, that's a thing. And we could put that link in there. But I'll kill the recording and we could just kind of casually, end the thing. But let me just say, so thank you for watching the Shop Class Podcast, and we're here every week, Wednesday nights. Okay, talk to you soon. Okay, so let me just